is no ending. It's an infinite series. How to find the sum. Just looking at its definition first. An infinite series is the sum of all terms in an infinite sequence. How can we tell the sequence is infinite again? What is it going to have? The dot dot dot. So showing that it continues on, right? Okay. There's two types of infinite series. The first type is called divergent. Okay. Divergent are series that don't have definite sums because they add up to either positive or negative infinity, and so the sum can't be determined. Usually I just write positive or negative infinity. And then the other type, the type that does have a definite sum, a regular old sum, is called convergent. So I almost think that those two words kind of make sense, like just definition wise. Like when I think of the word divergent in my brain, my fingers go like this, diverge, like that. And that's what it means to diverge. So one, it could either go to positive infinity or it could go to negative infinity. So this one right here is actually an example of a divergent series, one that either goes to positive or negative infinity. And if you look, it's because, what are we doing each time to get from one term to the next, to the next, to the next? We're subtracting by how much? 6. Very good. So if you continue to subtract 6 forever and ever and ever and ever, what are you going to hit eventually? Negative infinity. You think numbers stop at 0, Liz? They don't stop at 0. You're going to hit negative infinity because it's just going to keep on getting smaller and smaller and smaller and smaller. So this one we would either say, you could say no sum because it doesn't have an actual number that it adds up to, or you can say that it diverges to negative infinity. Was this sequence arithmetic or geometric? Arithmetic, right. Arithmetic sequences are actually always divergent. They will never have a sum. The only example that goes opposite of that would be 0 plus 0 plus 0 plus 0, which is technically arithmetic. And what would that one add up to? 0. I will never give you a sequence like that, though. But it is the one, like, non-example. Any other arithmetic sequence will add up to either positive or negative infinity. Now for the ones that we're focusing on today, we're focusing on the geometric series that would have actual sums that we can add up. Geometric series might be divergent. It really depends on what the common ratio is. Do you remember what common ratio is again? It's the number that you... No, it's not a slope because a geometric sequence is not a linear function. It's the number you multiply by each time, yes. Good try though. I'm glad you're saying things. Some people ain't saying nothing. Okay. A geometric series is divergent, meaning it goes to positive or negative infinity, if the absolute value of the common ratio is greater than or equal to 1. And if you think about why that is, so think about if your common ratio is like 7. If you take a number and you multiply by 7, and then you multiply by 7, and you multiply by 7, and then you multiply by 7, you get these huge numbers. Which means when you go and try and add up those huge numbers, it's going to diverge to positive infinity. Most, but not all series that are neither of these two are going to be divergent. We're just going to focus on ones that are arithmetic and geometric in this class, and maybe you'll experience some that are not arithmetic or geometric in a higher level class. A geometric series will be convergent, meaning it has an actual sum if the common ratio, if the absolute value of the common ratio is less than 1. So if the absolute value of the common ratio is less than 1, meaning you're multiplying by like a half, then you will have an actual sum. Infinite series sum of a convergent geometric series formula. And again, this is only if the absolute value of your common ratio is less than 1. Here it is, the beautiful little formula. On the left-hand side, this is just showing you what the summation notation would look like. How can I tell that this would be an infinite sequence? Infinity. How can I tell that this would be geometric? Because I have an exponent, yes, the exponential function here. Alright, I usually use this formula that's on the right. You take your starting term and divide by 1 minus your common ratio. You can also just write it like this. Starting term times 1 over 1 minus the common ratio is the same mathematically. Choose your favorite. But we always have to think about, is it geometric? and what is the common ratio. Because if the common ratio is greater than 1, greater than or equal to 1, we're done. We don't even have to find it. But if it's less than 1, so like if you're doing like a fourth each time, then you'll actually get an actual number for your sum. Let's look at the first one. First one is written just in regular sequence notation. We have to first decide whether it is arithmetic or geometric, and we're going to figure that out based on, are we multiplying by a number each time, or are we adding a number each time? Multiplying? What would it be multiplying by? 1/2. Very good. Times 1/2 times 1/2. So the fact that we're multiplying by a number each time means that it is geometric. Remember, geometric still might not have a sum. It's really based on that, common ratio. So I know my common ratio, that number that I multiply by each time, is 1/2. Okay? So we just need to decide which of the two options was it. Let me go back to them. Is the absolute value of that common ratio greater than or equal to 1 so that it's going to diverge? Or is the absolute value of that common ratio less than 1 so it's going to converge? Converge. Yes, it is going to converge. I'm going to write that down. So I'm going to say the absolute value of the common ratio is less than 1, so it will converge. Does converge. And if it does converge, then we get to use our formula to find the actual sum. So the formula, the infinite sum, is our starting term divided by 1 minus the common ratio. What is our starting term? 1/3. Very good. I'll plug that in up here. Divided by 1 minus, what was our common ratio? 1 minus 1/2. Some of these are so easy to calculate, you might not even need a calculator. Promise you. On the bottom, if we simplified, what's 1 minus 1/2? 1/2. So that would be 1/3 divided by 1/2. How do you divide fractions again? You learned in the 6th grade. Keep, change, flip. Change this to multiplying. Flip the second one over to be 2/1. And you get top times top, bottom times bottom. 2/3. All right, let's sit and think for a second. Okay, so a lot of people always get this answer and they're like, but how? But how? How is it possible that we could get an actual number if we add up an infinite number of terms? How is it possible that I can get an actual number? Let's think for a second. Let's discuss in our groups and see if we can discuss how that's even possible. Let's talk to our neighbors. How do we think that's possible? Well, let's go. How is that possible? Oh, I heard Liz say the right answer. Good job, Liz. What are we thinking? Oh, I heard it back here too. Not really that it's never zero. That it gets so small. Did y'all come up? Oh, it can't be the only word that doesn't know. Come on, brain. Big brain. The other one. John. All right, let's come back together. I'm gonna have John say his perfect answer. What was it, John?
So basically, all the numbers you add on together are so small to the point where it doesn't really affect the whole number.
Yeah. So think if you're trying to find the sum of all those numbers, every time that fraction gets smaller and smaller and smaller and smaller and smaller, till where you end up with the tiniest little fractions. Like their decimals would be 0.00000000001. Is that going to really change the value if you add that on? No. So eventually you add such small numbers that it kind of maxes out and you never go above a certain amount. I heard Nicholas say a good word to help us remember. It's kind of like an asymptote where you're never going to, it's like that point where you never touch it. So ours would be, we'd never touch 2/3. We say 2/3 is like the max. That's what we're going to get. It's never going to be above 2/3. Got it? Cool. Okay. Does that make sense? Okay. All right, let's look at the next one. Look at how the signs go back and forth, back and forth, back and forth. Can that ever happen with an arithmetic sequence? Can you ever add a number and it just flip-flops with the signs? So already, what do we know about it? What type of sequence is it? Geometric. Geometric. Okay. For geometric, again, let's look at the two possibilities before we start calculating. We have to figure out the common ratio because we're trying to figure out, is it greater than or equal to 1? It's going to diverge to positive or negative infinity. Or is it less than 1, and therefore we're going to have an actual sum. All right. If you've ever had trouble figuring out what the common ratio is, we talked about this on the day we learned how to write the sequence equations. We said if you ever don't know what the common ratio is, you can take any term in the sequence and put it over the term right before it. Term before it. And then you can just simplify it. Term before it. So like I can take 4 and put it over the term before it, which is negative 20. And 4 over negative 20 would simplify to negative 1/5. Is that what you said? What did you say?
That's what I thought. I said 1/8, I think.
Oh, okay. Let's see. 4 divided by negative 20. Math 1. Yes. Negative. Oh, what did I tell? Oh my goodness. I did negative 20. Yes. Math 1. Negative 1/5. There we go. Okay. So again, thinking about those two options. Was the absolute value of the common ratio greater than or equal to 1? So it's going to diverge to infinity or negative infinity. Or is it going to converge to an actual number? Converge. So if it converges, we're going to use our formula. A1 over 1 minus the common ratio. I'm going to have you guys do this one in your group. Again, these are so easy that you could use mental math to simplify them. But I know some of you guys with the fractions, you might need a calculator. Let's do 2 minutes on the clock to get this one plugged in and simplified, and then we're going to check the answers with our group. See if you could try and do it without a calculator. I bet you can.
Yes, he's never been to Chipotle before. Okay. Oh my gosh. No, wait, I've gone to no, bro. 10, 0, 1, oh my gosh. Every time I go to Chipotle.
You get 6250.
I think this might be the one that if you try and do it on the calculator won't give you a fraction. The number's so large that it gives up.
No, you do a fraction. Oh, dang it.
There was one that we did it earlier and we couldn't get it.
65.
Good.
Good job.
Like your hand stopped working. All right, 20 more seconds. I'm going to start writing my work while you finish it up. Alright, so when I plugged in my starting term and my common ratio, coming back together? Alright, when I plugged in my common ratio, I got negative 1/5 down here. That would be 1 minus the negative 1/5, which would make 6/5 on the bottom. If you use your calculator, it's pretty simple. If you want to flip the second one and multiply, you should get the same final answer either way. What if we keep our answer as a fraction, what's the numerator? 6250, good. And the denominator? 3. Perfect. All right, before we go on to the next one, I'm just going to kind of show you something in case you see it on the homework before we do the next one. All right, on a bunch of the homework ones, these sequences are not written in regular sequence notation. They're written in summation notation. Okay, so I'm going to show you how to kind of figure out what the summation notation would be. Remember, that's the one that looks like the giant calculus symbol. On the bottom, it would say that we're starting at the first term. What is our first term? Or actually not what is. We would just say, what would we write on the bottom of this? I equals 1, n equals 1, something like that. On the top, what would it be? Infinity. If we're going to dot, 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 that would be infinity. Good job. Come on, infinity symbol. And then we'd have the geometric rule right here. Remember, for the geometric rule, the first part of the geometric rule is your A1, and then you have your common ratio to the power of n minus 1. Actually, I think for ours we would have I minus 1. So if I had my A1, what would be right here? 2500. And what would be my common ratio? Negative 1 over 5. Okay, so on the homework, when you get to it, some questions might be written in regular sequence notation, and some of them might be written in summation notation where you have to pull all the information out of the equation. Ready to try the next one? All right, let's look at it. Okay, regular sequence notation. We have 1/2 plus 1 plus 3/2 plus 2 plus 5/2. So again, what are we going to start by finding?
What are the types? Arithmetic.
Arithmetic or geometric. Are we adding something or are we multiplying by something? Adding? What are we adding each time? 1/2. Well, that's nice. What type of sequence is it then? Arithmetic. So do I even have to use my formula? No. Arithmetic. You don't need your formula. What do we get to write for arithmetic? No sum. Well, you could also say what it diverges to, whether it diverges to positive infinity or negative infinity. No sum. Would this one, if we're continuing to go up, would it diverge to positive infinity or negative infinity? Positive, yeah. Because it would just keep going up forever and ever and ever, and you'd add these larger and larger and larger numbers. Diverges to positive infinity. The minimum of what you should be writing, though, is that there's no sum. All right, let's see if we can get this one last one all by ourselves. Let's talk to our neighbors. I'm not even going to tell you if it's arithmetic or geometric. I'm not going to tell you if there's a common ratio. We're going to do 3 minutes so you can get it fully answered.
Figure that out pretty fast.
Remember the trick? If you're having trouble figuring out what the R is, you take any term, put it over the one right before it.
What did you actually find the R? Oh yeah, so it'd be 972 over 1 plus infinity. Divided by 1 plus. So 582.2, right? Yeah, I did it correctly. Good day, Miss Moss. Oh, there we
Yeah, it's negative. That is 1 plus 30. Oh,
Did we figure out whether it was arithmetic or geometric? It is geometric. Is the R a positive number or a negative number?
Negative.
Negative. Okay, so that's your R. R equals 2/3. So is the absolute value like greater than or equal to 1 or less than 1? Absolute value. Greater than or equal to 1 or less than 1? Less than 1 means we don't use our formula. Alright, I'm gonna speed run mine. 5 seconds.
I found it. This one,
Alright. Geometric, you're correct. It is a negative common ratio. It's negative 2/3. Substituting that in, we'd have our starting term divided by, I saw a few people make a mistake right here. It should be 1 minus that negative common ratio, which would turn to 1 plus 2/3. We could come back together. What is 1 plus 2/3? 5/3. So now it's 972 divided by 5/3, which would be the same as having 972 times 3/5, which is, what's the top? 2,916 over 5. This one is a terminating decimal. It has like an actual ending point, so if you wanted to write the decimal, you can. Okay, and now for my favorite questions. Put the calculator to the side. We're going to do these without the calculator, because everyone's like, why can't I just type it into my calculator? Because this is a fun party trick. You're going to go to college and be like, look what I can do, guys. Watch. Okay. We have a repeating decimal. 0.24, 24, 24, 24, 24, 24, etc. We can figure out what that fraction is without having to use our calculator. Okay? It's a fun party trick, like I said, because a repeating decimal is actually an infinite series. It's just an infinite series where we already added it up. Okay? If we think the numbers that are actually repeating are the numbers 2, 4. These are the ones that repeat. So the first term of our series would be 0.24. And then we'll have a plus sign. The second term of my series, I have a 2, 4 in the, what does that be, tenths, hundredths, thousandths, the thousandths and 10,000 spot. Basically decimal places 3 and 4. So the number I would have to add to get a 2, 4 in these spots right here would have to be 0.0024. Because mental math, if you actually put it down, what did I just say? If you added these together, what would you get? No, you wouldn't. What would you get? 0.2424. And then if you put another one that had 4 zeros, you would get 0.242424. And it would continue on, plus dot dot dot.
Also, would we just put 0.0024 or 0.24?
We'll get there. We'll get there, Nicholas. Slow down. I know. Okay. So again, this is an infinite series. It is geometric. We are actually multiplying by a number to get from one term to the next term. So if we think about what our starting term is, our starting term is 0.24. What are we multiplying by? Not 8. What are we multiplying by each time? 0.01 or 001? No, just 0.1. R equals 0.01. Mm-hmm. Mm-hmm. 0.24. 0.01. See? If I take this 0.24 and multiply it by 0.01, I get 0.0024. You're basically making it... Yes, yes. Okay. These two pieces of information, we're going to take them, we're going to substitute them into our infinite sum formula. On the top, we'll have our starting term. On the bottom, we'll have our 1 minus our common ratio, which was 0.01. 0.24 over What's 1 minus 0.01?
0.99.
0.99. Okay.
Put this into my
No, don't touch it. You don't need it. You don't. Ion, put it down. You don't need it. Okay. 0.24 divided by 0.99. You could make these both whole numbers by multiplying both of these by what? 100. That's like a third grade math thing. So that would give you 24 over 99,
Which simplifies to 8 over 33.
which simplifies to 8 over 33, because both are divisible by 3. There it is.
Same answer, though, with way less steps.
By doing what?
I just put 24 over 99 at the beginning because I knew 24 over 100 would be 0.24.
Does that work on the next one?
Perhaps.
Try it.
This
Try
one
it.
is not a fraction.
Dang it. Okay.
5.14.
Alright. If we look at the next one, 5.146. That 5 in the front, we're going to kind of ignore. Basically, I know at the end my fraction is going to have a big 5 on it. So it's going to be 5 and some sort of little fraction. Okay, now let's think about what that series would be. That would be 0.146 is my first spot in this series. In order to get a 146 in decimal places 4, 5, and 6, what are we going to have to add? 0, 0, 0, 146, etc., etc., etc. 0, 0, 0, 0, 0, 0, 146.
So we'd be multiplying by 0.001 this time.
Yes, good job. So for just this part of the series, we know our starting term is 0.146. Nicholas already told us our common ratio is 0.001.
So we can already plug it in.
Mm-hmm.
Yeah.
Yep, you sure can. So if we do our infinite series formula, we'd have our A1 over 1 minus the common ratio of 0.001, which would be, let's see, 0.146 over 0.999. Your trick does work. Times what number to make them whole numbers? 1,000. And you would get 146 over 999, which I don't actually think reduces, because the top number is not divisible by 3, the bottom number is not divisible by 2. So the last thing I need to do for my answer, I need to put back what I initially took off, which was the 5. 5 and 146 999ths.
Just put it right in front.
Yeah, you can put it right in front. Do y'all remember how to turn a mixed number into an improper fraction? Old second grade men? Yes, you multiply these two and then you add the top. Yes, you can have a calculator for that one. It's 5141 over 999. There you go. And now whenever y'all go to college and go to parties, you can show people that.
We'll grab my little calculator at the party.
And be like, guys, watch this, watch this. Okay, let's get our DOL done.